Hello everyone, from today we are going to learn binary search, and I have included some questions, like I have included 12 questions, and in future I am going to also include some advanced question on binary search. So let's start. From very first question, in that first question I'll also explain the binary search concept. So let's start and read the question, what the question says. So given an array of integer nums which is sorted in ascending order. You have to remember this word sorted, and an integer target. Write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. So let's try to understand what question says. Okay, let me remove this. So we are given an array. Let's say 1, 2, 3, 8, 9, and 12. Have length like what is the length of this? 3, 3, 6. So n is 6. Okay, so this is sorted. Okay, and we are also given a target value, which is, let's say it is now 9. We have to return its index. Now for simplicity I'll just want to print yes or no. Okay, when we are going to print yes when the target element is present in the array, and when we are going to print no when the target element is not present in the array. So let's discuss the very first approach, which is naive approach, and or you can say brute force approach. What is it? Like, we are going to each and every element and we will compare it with target element. If it is equal, then we will print yes and we will return from the function. And if it is not equal, that means we will end the array, and we will end the loop, and we will print no and then return the function. So let me write it pseudo code quickly, because it's very easy to understand, like going to uh, going for each and every element and comparing with the target. That's it. From I to n, and we will compare with target equal to a of I. If it is equal, then we will return its index. Returning index means like return I. After that, if we will end the loop, that means we haven't find any target value, so we will return -1. So this is the pseudocode of brute force approach of this solution. So what is the time complexity of this solution? Is time complexity is big O of n, and space complexity is constant because not we are not using any kind of space. Okay, so the question demands to solve this problem in log n complexity. So how we are going to do that? Let's see. The second approach is binary search. Okay, so let's rewrite the array. Like, we are given 1, 2, 3, 8, 9, and 22. This is the array we have given. Okay, so let's do its indexing as well. 0, 1, 2, 3, 4, and 5. So we have to search. This is the search space. We called it search space because we have to find the target element in this search space, so we will we will having two pointers, like one is here pointing to the very first element, we will call it low, and the very and the high, which is pointing to the very last index of the array. And for using this low and high pointer, we will calculate its mid. So let's calculate its mid. How we will calculate its mid? Mid is going to be low plus high divided by 2. What is low and what is high? Low is pointing to index of the array, like it is pointing to the starting, so it will be 0 plus what is the high? High is 5 divided by 2. What is the 5 divided by 2? We are going to take floor. What is floor? Like if we calculate this, it will like uh, 2.5. Okay, the floor will take as a minimum value like 2.5, then I will take as a 2. Okay, so it will be 2. Let me erase this. Okay, so mid value is going to be 2 and our mid is here. This is our mid. Now what is our target? Target is 9. So we have to find 9 in the array. So for every binary search, whenever you are applying binary search, firstly you have to remember you only apply binary search in a sorted array. There is some case, there is a problem like we are not, there is not sorted array, but there is also applying binary search, but that case is different. But whenever you see a sorted array, you must think about binary search. Okay, so we will calculate mid. So in every binary question you have to assume that the mid value is going to be your answer. Okay, so in this case I am going to assume that 3 is going to be our answer. Assuming 3 is answer, now after assuming you have to validate your answer, like whatever you assume. Like in this case I am assuming that 3 is going to be my answer. 3 is my going to be answer, and then I'm going to validate with target, validate my assumption like 3 is valid or not. How we are going to validate it depends on the according to question. In this question we have to compare this with target. Array of mid, I am going to compare this with 9. If it is equal, that means our assumption is right and we directly return that. Like let me zoom out. And okay, so this is mid. So what is it? Let me change the color. Array of mid, if it is equal to target, this is my validate point. If it is this, then I'm simply return mid. If it is equal, in this case it is not equal. So in a binary search we will reduce the search space. Like we have a search space of length n. Now we will reduce the search space either from the left, this is the left, and this is the right, according to the mid value. Like in this case we have a mid value is 3 and which is not equal to target. Now we have to move either left side or the right side. We have to reduce the search space. How we are going to do? Because it is sorted, I'll compare this 9. 3 is 9 is greater than 3. 9 is greater than 3. That means the target element might present in the right side. Why? Because it is sorted. That means in the right side, the element present in the right side, it is greater than 3 or equal to 3. It is not going to be less than 3. So I'm 100% sure that my target element is going to present in the right side. So I'll simply move to the right side. How we are going to move? Like for now our low pointer is pointing to the very first index and the high pointer is pointing to the very last index. Now I am sure that my element is present at the right side, so I'll take the low element and point to the mid plus 1 element. Like now low pointer is pointing to the mid plus 1. Okay, so my search space is reduces to this much. This is the search space now, and this will gone. Now this is my new low and this is the high. High as it is, because I'm moving to the right. So if it is not equal, let me undo these things. Okay, if it is not, okay, so if my target element, like if my target equal to 3, let's target equal to 2. Now I will compare to the mid. It is less than 2 is less than 3. My mid is 3. Okay, so mid is greater. It means that 2 is lesser. That means I'll go to its left. Why left? Because the my target, for sure my target is present in the left side, because whatever the element present in the left side, it is always less than 3. So I can search surely that in the left side. So I'll remove the right side. How I'm going to remove right side, like my high is pointing to the last index. I'll this take this high pointer and point to this mid minus 1. Okay, so this is the binary search. We will every time we will calculate mid and we will reduce the search space. Like this is the search space and this is the search space according to mid value. Assuming mid value is our answer, then validate that assumption. If it is wrong assumption, then we have to either go left or either go right. Okay, so let's write the code and pseudocode, then you will understand better. So let me write this. Mm, okay, so let me write the array first, and then according to that we will write the code as well. So 1 2 3 8 9 and 22. Okay, let me write its index as well. 1 0 1 2 3 4 and 5. Okay, now initially my low is pointing to here, low, and this is high. Okay, we will calculate its mid. So mid will be here, mid. Okay, so let's create a pointer. So low. Okay, so I am writing code. Low is pointing to 0 and high is last index, so it is n minus 1. Okay, now when the loop end, when the low, until my low is less than or equal to high, loop continues. If the low is greater than the high, that means we will exhaust the all the elements, and we will not having any target element in the array. Okay, so this is code. So first of all we will calculate mid. So mid equal to low plus high divided by 2. After calculating mid, we will validate our assumption that this mid is following the condition or not, like our target is equal to mid or not. So array of mid equal to target. That means we will return here mid, because we will find the target value. Now if it is not equal, then we will compare array of mid with target. If array of mid is greater, if array of mid is greater than target, means target is less, so we have to move left side. So how we will going to move left side? So we will simply take the pointer of high to the mid minus 1. Okay, else if array of mid is less or target is high than array of mid, then we will move to the right side. So how we are going to move? It's low, mid plus 1. So that's it. If my condition of while loop like reaches this, low is greater than high, then the loop is end, and after that I'll just return -1, which is representing there is no element which is equal to target. So always remember, low is always less. Low is always less than high or equal to high. Okay, this is the condition. So this is the binary search. And what is the time complexity? Time complexity, every time we will reduce the search space by n by 2. Okay, so this is not n by 2. Okay, let's say we have this n, we will reduce the search space by n by 2, n by 2. Okay, let's say this uh, left side, it's there is no target element present, so we will search for this right hand side. This is n by 2 elements, and we will, if there is no, we will calculate for here mid value, and if there is no not present, then we will go to its left or will go to its right. So we will again dividing n by 2. So it looks like we go 1 second, n by 2 plus and then we are doing 1 second, n by 2 plus n by 4 plus n by 8, 2 raised to the power 3, and by 2 raised to the power 16. So this thing, and this is very close to log of n. So this is the time complexity of binary search, and I think you this is the code of the binary search, and you have to remember this. Because it is the essential for solving the another problem. This is the basic of I can say this is the basic, and let me show you code as well so you can understand. So this is the uh, creating a variable n and storing the size of the array, and creating two variable low and high, pointing to the first element and pointing to the last element. Loop, low is less than high. Okay, calculating mid, comparing with mid. If it is equal to target, then return mid, else I'll compare to the nums of target, and according to I'll reduce the left half of the and the right half. So this is acceptable solution, and this is the time complexity of this is big O of login. So that's about it. We will solve next 2 or 3 questions in a row, and for now, thank you.